Alright, really quick before we start the video. By the end of it, we should expect to have something like this. Ooh. One more time. Let's see if I can get up there. Okay, there we go. And so once we hit the flag, it says the end goal. Okay, let's get started. So although this is a two-part video, you don't have to watch the first part to understand this part, because the first part was same system I showed you, just made completely in blueprints. And this will be the exact same, but made in C++. So if you're short on time, I'll put a link that includes all the code that I've written, everything from the ball movement to the interaction components that the ball interacts with. And that's going to be included in a GitHub. And you'll find a link to that in the description below. Let me know how I can help in the comments below. With that being said, let's get to it. So I would recommend making some levels folder, just to keep things a little bit more organized. So I'm saving my level. Okay, so let's create our C++ component. So everything that we discuss in this video will be stored under, or I'm going to store it under an interactions folder. So I'm going to make a folder called interaction. And from there, I'm going to call this the interaction base. Okay, so I'm going to create that class. So as that's compiling, I'm gonna go through a little bit of the layout of what we should expect from this video in terms of the class hierarchy. So we're using the interaction base as sort of a test ground to see how interaction works in Unreal Engine. And just a spoiler alert, the way it works is that Unreal Engine has a pre-built interaction system. And this interaction system only works by allowing actors to communicate with each other. And the way it works is that by default, it allows you to interact with two actors. What we want more specifically is that we want our interaction, or I guess interaction base, to communicate not with an actor, but rather to communicate with this ball character. And this ball character CPP was just the name of the class that I gave it to move the ball in. So this would probably be a different name if you had a different character. So whatever name you gave your C++ class, that would be the name you would downcast it to. And by using the concept of downcasting, we're able to ensure that the class that it's interacting with specifically is the one that we're looking for. By using downcasting, we're able to target the class that we're looking for. In this case, mine would be a ball character, but yours would be something else. Yeah. So let's get to it. Let's see. So it created the folder, the interaction base. So I'm first going to start off by saying, let's see, I don't need the tick component, so I'm going to start off by deleting that. Let's get rid of that. And so in the interaction base, let's get rid of our tick component, since we don't need that. And we're going to set b can ever tick to false, because we don't want this component to tick every frame. And I also don't need the begin play, so I'm going to get rid of that as well. Okay. So I'm first going to start off by making a component, and the component I'm going to go with is just a static mesh. So I'm going to say I want a class static mesh or UStaticMeshComponent. And then I'm just going to call it static mesh. And I want to expose this to the engine, uProperty. And I'm just going to say edit anywhere and blueprint read write. Okay, so I'm gonna create an instance of I'm gonna create the static mesh in our constructor. So in the constructor, what I'm gonna do is create a default sub-object. Oh, let me just get rid of this as well, since we're not using the begin play. So static mesh equals create default sub-object uStaticMesh, and this uStaticMesh is the data type, StaticMeshComponent. So we notice this data type here matches our data type here. That's all there is to it, to create a static mesh. You do have to pass in a string argument, so I'm going to say text, and I'm going to say static mesh. It didn't have to be called static mesh, but I just called it that. Static mesh. The name doesn't affect anything. So now what I'm going to say, I want to make it so that the collision for the static mesh is not blocking anything. So it's allowing things to go through it. And we can do this by saying the static mesh set collision profile name text overlap all. And since we're setting it to this overlap all, that means that if there is if our interaction component won't block our ball from going through it, so the ball can just go through the component. And we would want this just so that we can see exactly where the interaction occurs between our two components. So this is the fun part. So now we want to simulate what an interaction is. So the way that interactions work in Unreal Engine is that you have a concept of a delegate. So not every, but a lot of components have access to delegates. So if I say static mesh and then I do a pointer and on component begin overlap, component begin overlap. So this on component begin overlap, add dynamic. And then we're going to pass in the user object, and that user object is the current state of our class, and the second is the function name. So the function name, I'm going to name this function WhenTouching. So I'm going to pass in the address of interactionBase, AActor, and I'm going to say WhenTouching. So the idea is that, so I'm going to create this function. The idea is that when two components are overlapping with each other, call this function, WhenTouching. Now we didn't really make this function so far, so I'm going to go into my header file and I'm going to make that. So void WhenTouching. So let's just make, okay, so we have this line here, and I just want to go through what this is saying. Or actually, let's just go through all the lines in this constructor. The first one is creating a static mesh so that we can use it in the editor. This one is setting the collisions of that static mesh so that anything can overlap with it. Any actor can overlap with our static mesh. Now in here, this WhenTouching gets called, this function gets called not by us or by the Unreal Engine framework. And this concept of allowing the framework to call our functions is called inversion of control. So just really quick, scroll here. Inversion of control, instead of us having to call our functions, the framework calls into the custom task specific code. So we want this function, WhenTouching, to be called whenever two components are touching, but we don't necessarily know when that happens, which is why we're leaving this task to be called not by us, but by the Unreal Engine framework. And so sort of to relate this to the video I made about intro to classes and functions, I said in that video that in order for our code to affect the program, we first need to make an instance of our class, and then we need to call a function using the dot or arrow operator from that class. So in this case, by us passing this, the Unreal Engine framework now has an idea, or it knows the current state of our class. Because all this is it's just a pointer to our class. So if I were to say AInteractionBase pointer random actor, and if I say that's equal to this, that's what this gets assigned to. So you notice that it's uncomplaining, and that's because all this is the current state of our class. So whatever transformation it has, so whatever x, y, and z coordinate it has, in this current instance, pass that into this add dynamic here. This WhenTouching, that's just the function call. Because we know that like when we call a function, random class, and then we use the arrow or dot operator, and it would be followed by our function name. Well, guess what? We passed in the address of our function, and we passed in the current pointer of our function. So Unreal, from Unreal's perspective, it has everything it needs it has all the information it needs about our class, so it can properly call the function at the right time and have it affect the current state of the class. Maybe this will make sense more as we go through it. When we get this code done, I'll go through it again. So let's see, we have this WhenTouching. So since the engine is calling our function WhenTouching, that would mean that it needs to know about this function, and to allow the engine to be aware of this function, we're going to pass a macro in, and we're going to call this macro UFUNCTION. And we don't need to pass anything in the parameters, just because this UFUNCTION allows it so that Unreal Engine is aware of this WhenTouching function. And the reason we need that is because we're allowing it to call our function through this add dynamic. So any function name that goes into the add dynamic has to be aware of our function, and the way we're able to do that is by passing in this UFUNCTION. Let's get rid of this line. There is a caveat in this though, is that even though Unreal Engine is calling our function, the specific parameters that function takes, it can't just take in any parameter. So in this example, I said WhenTouching, but really like you would have to pass in this parameter list in here. So let me just copy that and paste it in here. So it's a pretty long parameter list. So the reason I'm not entirely sure about this, but the reason I think it needs these parameter list is because in order for you to delegate a function for Unreal to call, it needs to have a approved function signature. And that function signature gets generated by these parameter lists. I have seen some examples where people do this, where they have this parameter list, where they have these two actors, but I haven't personally tested it. So you could try, I guess this would be WhenTouching. So the moral of the story here is that we can delegate our functions, or delegate the call to our functions. We can delegate the call to our functions to Unreal Engine, so it calls our functions instead of us. But the condition is that it has to have a pre-approved parameter list, and I know this happens to be one of them through the documentation, which I'll link below. But I've also seen people do this as well, so you could try either one. But you still have to make sure that those get followed by a UFUNCTION. So each one of these parameter lists still has to be followed. Each one of these signatures still have to be followed by a UFUNCTION. So with that being said, I'm just going to delete the first one, and I'm going to delete this one. And I'm going to stick with this one because this is the one I saw on the documentation page. Okay, so just to be clear, I named this WhenTouching, but you don't really have to name it that. I just named it just because in my head, when two interactions occur, it occurs in the event that one actor is touching the other actor. And that's the only reason I named this function WhenTouching. Yeah. And so I'm going to right click and I'm going to create an implementation. So now we have our implementation and we have our add dynamic. So from here, what we can say, is I just want to make it so that when it does interact, when our item is interacting with our ball, I print something to the screen. I'll say uprint string, and this is like a code snippet, and so this is like what you would write in your editor. And I'll just put second argument is I'll just put 5, and color is red. That's fine. Text, and I'll just say touching delegated function being called. Okay, and with that, you would also need to make sure that certain things are defined. So I'm just going to say if other actor, which is this, and so the other actor would be the thing you're overlapping with. So in our case, maybe it could be the ball, but then it could be another actor as well. So if other actor is defined, and the other actor isn't our current item, we want to make sure that the item is not interacting with itself. So we do that by doing this, and the other component is defined. So now we're going back to our diagram. This is where the casting happens. So we have in here, we have our ball character, and that's just the name of the class. So if we go back to my code, I have this ball character, a ball character. That's the code I wrote to make the ball move. And that's also going to be included in the GitHub. So I want to say if this other actor can be downcasted to an a ball character. A ball character. Yeah, let me just copy the name. Okay, so I'm just going to copy the name, a_ball character. I'm going to paste it in there. So a ball character, pointer, overlapping ball. And I'm going to say cast, and then in parentheses, it's going to be the thing it can be casted to. So in this case, I have a ball character, so it would be just a ball character. Okay, that did not work. Cast, I'll just type it in. A ball underscore character underscore CPP. Okay, so with that, and so this is the thing it casts to, but then in the parentheses, it would be the thing we're trying to cast. So we're trying to see if this other actor can be casted to a ball character. So in this case, in relation to our diagram, can we take our actor and can we cast it into this ball character? If that's possible, then we know in fact that the actor we're overlapping with is an actor we want an interaction, or we want the interaction to occur with. So in our case, I'm just going to draw a globe, but really you could have done anything with that. I'm going to say other actor. So if the cast is successful, we can check for that by saying if overlapping ball is defined. And also I'm just going to make sure that it's not a null level. So get world. I want to make sure the level is also defined, or the world is defined. So if the cast is successful and the level is defined, then execute the code in here. And so what I want to say is I want to make a function, and I'll just say, I'll call this function interact. Interact. And essentially, I'm just gonna, so when the conditions have been met, and we know that in fact the thing that we're overlapping with is a ball character, call this function. So I'm gonna call this interact, and let's see, and our character, so we know that we're interacting with a ball character. So I'm gonna say a underscore ball character underscore CPP and pointer overlapping ball. Okay. And I'm going to create an implementation for that. So I'm going to right click, create implementation. Okay, so I have this interact. So it's going to interact with a ball character. So I'm going to pass that in here. So overlap. Oh, let me just copy it. Okay. Okay, so we have our overlapping ball. And from there, okay, just really quick. Cast it to see if the thing we're casting it to is in fact a ball. If it is, then call this code. That's all this translates to. So what I want to do, it's just going to be mostly testing. So I want to make it such that when two actors are interacting with each other, draw a globe. So to do that, I'm going to use the Kismet library. And if you're going to use the Kismet library, then you're going to have to include this header file. So I'm going to go in here and include this header file. One thing you would also want to include, not necessarily sure if this is included by default, but just to be safe, I'm going to include the static mesh. Since there's header guards, if it was included once, it's not going to include it again. And I think that's about it. So we have our interaction. So now I'm going to use the Kismet library, and in the Kismet library, what I'm going to call is the draw debug sphere system library draw debug sphere. And the arguments it takes in would be, so the reason I checked why the get world is defined is because this draw debug sphere, if I do F12 on it, hopefully it finds a definition, it takes in a UObject world context object. So before I even pass it into this debug sphere, I want to make sure that the world is defined because I'm using it in this function call here. So I'm gonna say get world. And then from there, I'm gonna say, let's see. So the first argument is the world, the second is the center, so where the interaction's occurring. And I want this interaction to occur when the ball is overlapping. So in this case, when our overlapping ball, like I wanted to draw where the ball overlaps with our item or with our interaction base. I'm treating the interaction base as an item basically. So interaction, so overlapping ball, that's the arguments I'm passing in from here. So overlapping ball. And then from there, I'm going to dereference it. And I don't need to be worried if it's null because I've checked if it was null in this condition here, where I say is OtherActor defined, and OtherActor in this case is just, I checked if it was null in here. So if it was null, it wouldn't be going through this. It wouldn't be going through this if condition. It would just skip it. So that means I can properly dereference it without the engine crashing. So get actor location. So this would be the actor location of our ball. So yeah, So when our item is interacting with our ball, draw a sphere at the location of the actor. So by doing this, we properly know where the interaction is happening. So the third argument is the radius. So I'm just saying the radius is 10. And the fourth argument is the segments. So how many lines should be on that sphere. So the more lines you have, the more detailed the sphere will be. And the fifth argument would be the color, I believe. F-line color, yeah. And so to specify the color, all we have to say is F color, and I'll say white. I think there's a bunch of colors you can pick from. The last argument, or the duration, so how long should the sphere be present and how thick the sphere is. So in this case, I'm going to say the sphere is 4, so it should last 4 seconds, I guess. Yeah, 4 seconds. And then the thickness, we'll just keep it at 2. So a lot of these numbers, you can like just play through them, just see which one works best for you. Yeah, so let's see if this compiles. Okay, so we got a compile error. And let's see. Overlapped ball. Oh, wait. Oh, void. So it's complaining about this line. Oh, okay. It doesn't know what an overlap ball is, and that's because I didn't include the header file. So in here, since it doesn't know what an overlap ball is, I wanted to not worry about that, so I'm going to forward declare it. And then through that, so that's going to get rid of that issue. But we need to know what an overlap ball is in this function in here. So to do that, we need to include the proper header file. So our overlap ball is, so it's going to be, I'm going to include, so I first need to get out of this interactions folder. So I'm going to do .. And then since I'm out of it, now I can just say ball underscore character underscore CPP. And then it's going to be a .h. It's kind of confusing that I put CPP in the name, but then I'm including the header file. So hopefully that fixes it. So let's run that again. Okay, so it's complaining about let's see. Kismet. Nothing in the header file. Syntax error. Oh, okay. I missed a semicolon in here. So that should take care of that. Typically, and I forgot a semicolon there as well. Yeah. So although Visual Studio Code is complaining about these lines here, sometimes when you mess up in a line above or below, it will complain about the line underneath it or above it. So we'll just make sure if that fixes it. Cannot convert argument 1 from a ball to, I think I misspelled this. Oh no. Okay, so I'm just gonna go in here and then copy the name and then go into my header file and paste that name in here. Okay, so this is the data type. Let me get rid of this and put a pointer in there. Get rid of this. So that should take care of that. And then in here, I have the overlapping ball. And just gonna create the definition again. Create implementation. And I'm just going to copy this code and put it in there. Get rid of this code. So save that, and then hopefully that fixes it. So I'm going to do Shift-Control-B, and let's see. Okay, so at the end of the day, it was just the way I spelled my function declaration. So I wasn't liking that. So compiled fine. So now I'm going to do an editor compilation. And once we get it to compile in the editor, we're going to be testing it out as we showed in here. This AInteractionBase. We only make this just to test out our interaction base. And as we're testing it, I'm going to go through which line of code kind of corresponds to the actions we've done, or which line of code corresponds to the actions we're seeing in the screen. So I'm going to minimize that, and then we're going to wait for the compilation to end. Okay, so it compiled in the editor. And so we have our ball character CPP. Character. So this is our CPP ball character. And I'm just going to get rid of this character here. We don't need that guy. Okay, and now I'm going to go into my interactions folder. And I have, for some reason, I have two interaction base, which is really weird. I'll make a new folder and I'll call it CPP interactions, I guess. That would work. So, new folder. Oh. New folder. CPP underscore interact. Actions, okay. Okay, so the engine seems to be acting a bit strange, so I'm just going to close it and open it again. Okay, so closing the editor and opening it again seem to have removed that strange two interaction classes being there. So I'm going to say BP underscore interaction. And I'm going to put that in the CPP underscore interaction folder. Okay, and then from there, I'm going to do my static mesh, and then I'll make the static mesh be a cube. So cube, and I'm going to scale this down by half. And I'm going to compile that. Okay, so we notice that it's overlap all. So the reason it's set to overlap all is because in our line of code, in here, we set it to overlap all. And so since we set it to overlap all, it corresponds to the editor setting it in the settings here to overlap all. So we have that. And yeah, since we created the default object, we can see it in the editor, so that corresponds to that line of code. And these two lines of code, or this line of code, is specifically for calling our WhenTouch. But in terms of like when to call the WhenTouching function, we don't necessarily know. So what we want to do is we don't want to worry about when the function gets called. So what we do is we're passing in the function address and the state of the class, and Unreal will call the function when it needs to, because it has everything it needs. It has the state of the class and it has the function pointer. And by doing this, we're essentially creating a separation of concern. We aren't concerned about when touching gets called, because we're leaving it up to Unreal Engine to call it when it has to. Yeah, so that's why we're using this add dynamic in here, because we want Unreal to deal with the function call instead of us. The concept of inversion of control gets used a lot throughout programming paradigms, whether it be like web development or hardware development. I might do a video about it in the future, because it is an interesting concept that you leave it up to the framework. You leave it up to the framework to deal with calling your function instead of you calling your function. Yeah, so maybe I'd do a video about it and show examples. But yeah, so for this video, all you need to know is that WhenTouching needs a specific function signature. And what we're doing is we're giving we're allowing Unreal to call our function instead of us, so that we don't have to worry about when to call a function. So there's a separation of concerns. So now, okay, so we have our, going back to the editor, we have our cube, and one thing I'm gonna do is I'm gonna have this cube, and let's see. So the overlapping actor is being called. Oh, interesting. So in here, it's drawing the sphere, but it's drawing it in the center. And I think the reason it's doing that is because if I go to my C++ code and go to my ball character, in my ball character, what I had done is I made the root component the scene component, and by doing so, what it says is, oh, the scene component would be just the initial point of where the ball starts. So if I happen to move this ball over here, or actually if I happen to move the ball, or move the ball there, we're gonna notice that when I run it, it's gonna call it where I was last there, where I was last located when I was spawned into the level. So if you do end up having this issue, a solution would be to go into your ball character where you have your character set up, and set the root component instead of the scene component. We would set it to, let's see, we'd set it to scene component. The root component would be the static mesh component. Static mesh. And actually I have it set up in here to create a scene component, but really we don't need the scene component at all. So I'm gonna delete this. So this is a little bit of a detour, but it's probably gonna be, I think it's useful to see these types of things in a development setting. So we don't need this scene component. Okay, so I'm gonna compile that, and we're gonna see if that fixes our issue. As it's compiling, I did notice that I set the static mesh attaching to the scene, so I don't need to do that anymore. So I'm actually gonna get rid of that, and just have it so that the spring arm attaches itself to the static mesh and the camera attaches itself to the spring arm. So I'm gonna save that, and it's probably gonna complain that, oh, we don't know what a scene component is. So hopefully, okay, so it failed. That was expected. And now we're gonna do this, and then hopefully that fixes it. Okay, so it compiled, and ooh, that's huge. So I'm gonna delete that, gonna delete this. So if we go in and drag our interaction, and now let's see if the interaction occurs. Oh, okay. So we noticed that, our CPP ball class is now interacting with our static mesh, and it draws these globes, and these globes get called not by us. So WhenTouching being called, so Unreal Engine is calling the WhenTouching, and it calls it when at the point where this globe gets drawn. So at that point, that's when it starts to call our interaction function. Yeah, so the globes get drawn because of this line of code, and this line of code gets executed in the first place because it was called through Unreal Engine, because we had this function signature, and then we passed in a pointer to that function, and then from here we cast it. If the cast succeeds, then we find that the globe is in fact interacting with our ball. If the cast fails, actually we should have a condition when the cast failed, and sort of test out when it should fail. So in an event that the cast does fail, I'll say uPrintString, and let's see. Let's go with blue, and then I'll just say. So in the event that the cast does fail, I'll say the actor could not be casted to a ball. Okay, so I'll compile that and really quick. Test it out. Okay, so it compiled for the editor. So now we're gonna go in here, and I'm gonna bring this ball in here. And so in the event that we have our ball, we notice that it's drawing the globes and it's saying WhenTouching being called. But let's say we use an actor that can't be casted to, let's say we use an actor that can't be casted to a ball or a CPP ball. And in this case, I do have one, which is our equivalent blueprint ball class. And so if I get rid of this CPP and just run this ball blueprint ball class, and then I try to interact with it, we notice that it says, it's a little bit hard to see, but it says the actor at the very top, the actor could not be casted to a ball. I guess it's really hard to see, but that's what it's saying at the top left. So again, just to rephrase, the reason that cast failed was because our blueprint class in here was deriving from a BP underscore interaction base. So it was deriving from like a blueprint actor. And that means, and since it's not deriving from this parent class in here, where it contains all our code for the C++, it won't be able to be downcasted to this specifically. And because of that, our interaction base will say, okay, this actor that you're interacting with in here isn't one that contains this code in here, but rather one that contains this blueprint code, in here. And because of that, because it doesn't inherit from this class, that means it can't be downcasted to that, and so that's a case in which it fails, in which the cast does fail. So we have the two use cases. One where we have our C++ class. It's able to call the globes and it calls a function. But another situation a case where it does fail, where we have our blueprint class and we're trying to interact with our interaction base, but it's saying it can't be downcasted. So this function in here, this cast, this other actor, will really be any actor. It could be a blueprint actor, it could be a C++ actor, but really the key point is in this line here, where when I do the cast, I'm specifically asking for a ball character, so an actor that specifically contains this piece of code. And so because of that, and then I can call the interact function. So going back to the editor, we notice that our interaction happens now. Now we can move on to the next. So we are able to, from this diagram, we were able to cover this interaction portion. So we're able to get this one done. And what we're going to do is we're going to create 3 child classes that all derive from that, so that we don't need to rewrite this interaction base. And a function that we would override would be the interact function. So instead of just drawing the globe, I want you to do specific things that, like a pickup is representing our coin. So a coin would be like, the way that we would interact is just like, okay, once you touch the coin, destroy the coin. And then for the goal, it's just print a string on the message. And then for a JumpPad, we're going to say, oh, okay, when you're interacting with a JumpPad, change the character height to go this high. So it doesn't really matter what order we decide to create our pickup classes, since they all have their own separate responsibilities. I'm just going to, for this video, I'm going to go for creating the pickup, the coins, the JumpPad, then the goal. Just because I find that the pickup is the most complicated, and then the JumpPad is second most, and then the goal is probably the easiest one. So we're just going to start with that. The C++ class, I want to right click. So the way we're able to represent inheritance in Unreal Engine, so we say the pickup inherits from interaction base. The way we're able to do so is we right click on the interaction base, create C++ derived class. So from there, and then I'm going to call this pickup. So everything that's part of our interaction base will by default be included into the pickup. So create class. So it added it, but it needs to be recompiled. And usually when you get an error like this, it usually means that the header files that got included, it didn't include the right header files. So we're going to say yes. And we're going to go into our C++ class. And in the pickup, we notice that, okay, as we notice, there is an include path error. So it says in here, pickup.h, line 6. Yeah, so it includes interaction base, but it doesn't need to do that for the interaction. It just needs to include the interaction base because they're in the same directory. So I'm just going to delete that, and then that should fix that error. Okay, so it compiled successfully. Okay, so now in the pickup class, what we're going to do is, okay, so really quick, just to visualize what our pickup is supposed to do. Recall that we had our ball, and let's get a coin. So our pickup, there we go. So this part was made in blueprints, so run it. So really quick to visualize this, what we do is when we get close to the coin, what it does is it drags it from its location and then it attracts it to the ball's location. So having a current reference of the ball helps us accomplish this because we know where to attract the pickup to. So just a quick heads up, in this point of the video, I was thinking that having a reference of the ball character in the interaction base would solve all our problems for it knowing the location of the ball in all the children classes. But we find that that actually won't help in regards to the pickup. This piece of logic that we're currently going to go through is going to help a lot for the JumpPad, but it won't help that much for the pickup. So just be aware of that before going into this part of the video. So one thing I also want to do in the interaction base is that in my interaction base, I do know I'm able to make this cast. So I know that I'm interacting with a character. So what I want to do is just store a reference to this overlapping ball. And so in the header file, I'm going to go in, I'm going to make a U property. So in the header file, I'm going to take a U property, paste that there. We don't need any of the arguments. And then I'm going to forward declare a ball. Okay, and then I'm going to say overlapping ball, character. So I declare it here, and then in the interaction base, once I'm able to cast it and the cast is successful, what I want to do is just store the specific reference of that character. I'm going to copy this. I just copied the name. I'm going to paste it in. And I'm going to say that overlapping ball character is going to be equal to the overlapping ball, which is the thing that was successfully able to be downcasted. Okay, so I'll compile that. And by doing this, when an interaction occurs, I still know what my interaction component is, or what my item is interacting with, or it has information of the ball that it interacted with. So now we're going to go back through the editor, and I'm going to talk you through how we were able to make the attraction rate in blueprints, and then go on into translating that into C++. The way we're able to accomplish this in blueprints, so in our attraction rate, so right here specifically, so we have this attraction rate, which is just a timeline, so it's an F timeline node. And what we did in this attraction rate is that we had a curve, and what this curve was doing, what we did with this curve is, let's go back to the event graph. What we did with this curve is that we used the values that it was producing out of this curve. So in the case that the time was 0.09, that would mean the value is 0.02, which means at time 0.09, the pickup is 2% closer to the ball. We find that as we keep going along this curve, the value will increase, which means the distance between the two objects will start to decrease. And the reason that's the case is because we're using that value into our Lerp function, and the higher the alpha value is, the closer the two objects will be. In this case, we have object 1, which is our pickup, and we have object 2, which is our ball. So as the alpha values increase, well, you'll find that the distance between the ball and the pickup will start to decrease. So by it being 1, that means the value, that means the location of the pickup is exactly the same as the location of the ball. We were able to accomplish this in Blueprints through using a Lerp and using an FOnTimeline event. So since the C++ is just a translation of our blueprints, we're basically going to do that. So to start off, before we get into the code, we would want to make some sort of folder to store our graph. Or we would want to make some sort of folder, and this folder is, we want to make it so that it stores this graph. We want to make a graph like this for our C++. So it's something that the C++ can read from the editor and execute in its code. So I'm going to make a folder, and I'm going to call it curves. So in this folder, I'm going to right click, and then under miscellaneous, we'll find a curve. So I'm going to click on that. And then I'm just going to say this is a curve float. Yeah, that works. And then I'm going to create, and I'm going to name this magnetic attraction, because it's like magnetically attracting the pickup to the ball. So I'm going to double click on that. Okay. I'm going to left click, add a key. So this first key is going to be your starting value. So I'm going to put 0, 0. And then I'm going to right click and then add another key. And this other key is going to be 1, 1, 1. So the x value is 1, the y value is 1. So now we have our graph. Ooh, okay. And what we want to do is we want to left click on this, and then we want to set it to auto. And we're going to do that for this as well. Set that to auto. So now we have this graph, which is essentially mimicking our graph from the pickup. So now that we have this graph, we're going to go back into the C++, and let's see. So we're going to go back to the C++, and we're going to create our necessary components. So for our pickup, we would want to make a constructor. So we're going to have a public section, and the first thing we're going to have is a pickup. So this is just our constructor, and then we need this to create our components. Okay, and so we notice from our demonstration here, from the blueprints, it was rotating our coin. And so to get something to rotate, the way we're able to do that is we're going to create a component, and this component is going to be named rotating component, and then rotating movement. Okay. Okay. And what else? We need a sphere, because if we notice in our blueprints, if I left click on this, interaction and click on the viewport, if we go to rendering, we notice there's a sphere in this blueprint. And so what we're going to do is this sphere, we're going to attach to the sphere a delegate, and this delegate is supposed to basically activate our interaction. So in the event that something is interacting with our sphere, do something. And what we're going to do is, in the event that it does overlap, or it goes through our sphere, or the ball goes through our sphere, in the event that the ball goes through our sphere, make it so that the coin gets dragged into the ball. But actually, before that even, I would want to say the simplest thing we can do just to get things rolling is that we'll have this rotating movement. And from here, what we'll do is we'll override the interact function. So we're going to have our interact function. So since we're overriding it from our parent class, we're going to say virtual void. Actually, we don't even have to say virtual void, but it's good practice to say so. Interact. One thing we do have to do, though, in our interaction base, we have to mark this interact function as virtual, since we're overriding it in its child class. So back into the child class, virtual void interaction. Actually, I'll just copy this, since it's the same function signature. Virtual and then override. So then we have that, and we're going to create an implementation. Create implementation. So in the event that the implementation, or in the event that the pickup is being interacted with a ball, what do we want to do? Well, in the case of the pickup, what we want to do is when it is interacting with a ball, what we want it to do is we want it to destroy the actor. So what we're gonna first do is we want to still have the functionalities from the parent class, which is drawing the globes. So what I'm going to say is I'm going to use a super macro, and then I'm going to call the interact, and then from there I'm going to pass in the overlapping actor. So I'm going to copy this, and then I'm going to paste it there. So from here, what this line is doing is just call the parent functions interact, and all the parent functions interact is doing is drawing a globe. So it will call this piece of code here. But this piece of code will only be executed if the cast was successful to begin with. So, or right here, if the cast is successful, it will call this piece of code. So if we go in here and we have this super interact, and if so we have the super interact, and now when it's interacting with the character, so call the parent class's interact function. In addition, I want you to destroy the actor. And what this will do is it will destroy the coin once it interacts with the character. So really quick, let's just test this out just to see if it's working. Okay, so it's complaining that linker unresolved. So whenever you have a linker error, what happens is typically the function signature or the declaration doesn't match the signature. So it's complaining about internal constructor pickup. So let's see. Oh, okay. So the reason I got my linker error is because I declared my constructor in here, but I never defined it. So I'm going to create an implementation. And there we go. And then this should resolve the linker error because I declared my function and I've defined it in here. So since we already created our constructor, I'll just make it so that the things we can test is if the coin is rotating. Okay, so we created our constructor, and so what we can do in our constructor is we can create an instance of this rotating movement. You might be wondering why we're not creating a static mesh, and we don't need to because in our parent class we already have a static mesh, so we can just override that in the child class. So we don't need to create a static mesh each time. We can just use a static mesh from the parent, and we can override what default static mesh it's using. So in our constructor, I'll just have that be the first thing. So I'm going to paste that here. In our constructor, what we're going to be testing is we're going to create first. So what we're going to be testing is we're going to create this rotating movement component. So I'm going to paste that, create default sub-object, and then from there, I'm going to be creating a U rotating movement component. So This is the data type. I'm gonna just copy that and paste it here. And from there, I'm gonna be creating a text and rotating coin. Okay, so I'm gonna save that. And so now that with the code that we have in our header file, this constructor and then the rotating movement and the interact, what we can do with this is we should expect that we'll find a coin. We'll be able to assign a coin material. This coin material will be rotating, and as it's rotating, once we interact with the coin, it should be destroyed from the level. It's complaining about the rotating movement component, and the reason it's doing that is because I didn't include the proper header file. So to get the rotating movement component to be defined, what I can say is include this header file, and that should define that data type. So I'm gonna compile that. So I probably misspelled the rotating movement component. So what I'm gonna do is I'm gonna copy this, and I'm gonna go into the pickup.h, gonna paste it in, and then I'm gonna prefix it with a u. So class u rotating movement component pointer. Oh, I definitely misspelled this. Rotating movement, there we go. And then we'll get rid of this. Okay, so we'll get rid of this, and in the properties tab, I'll just say it's blueprint read write, just so I can edit this in the blueprint. Blueprint read write. Okay, so now I'm gonna go and compile, and let's see if that fixes it. Copy this data type, this is the correct one, and then I'm gonna paste it in here. And then I'm gonna save that, and I'm gonna compile that. Okay, so it compiled, and it was mainly because the header file was not included, and I specified the wrong type for the rotating movement. So now I'm gonna compile this in the editor, and then we're gonna be testing it out. I'm gonna have a class that inherits from the C++ or the pickup. So I'm gonna make a blueprint class, and then I'm just gonna call this BP underscore pickup. And I'm gonna store that under the C++ interactions folder. So then from here, we notice that we have by default a static mesh, and this static mesh is because it inherits from the parent class is the InteractionBase, and that includes a static mesh component. So because it includes that, it will be inherited to the child. We also notice that our rotating movement from the constructor is created in here. So what we can say is our static mesh, let's just say it's a cylinder. Okay, that's perfect. Yeah, and then we can just resize this to be 0.5. And I'm also change the material just to make it slightly different than the blueprint one. Okay, so I'll go with this pink one. Yeah, that's fine. So now if I take my pickup class and drag it into the level and play, we notice that our rotating movement ball, or our pickup coin, it's rotating. And so if I touch it, okay. So when I touch it, it doesn't seem to, it's blocking me. And I think maybe because something got screwed up with the physics, so I'm just gonna set this to overlap all. We did this in the C++, but it might have not transferred well into the editor. So we can override that manually into the editor. So now when I touch the pickup coin, we notice that it disappears, and it says WhenTouching being called. So all the code we have so far was just making it so that we can test a coin calling its parent function. So we did that here. And then we also assigned to it a rotating movement, and then we also destroy the coin once it interacts with the overlap ball. So now everything moving forward for this pickup class is mainly going to be to get the pickup coin to be attracted to the player. So essentially, it's creating all the components necessary to allow this to occur, where to allow this event to occur. So when I'm around a pickup coin, it just gets dragged by the player. So it gets dragged by the player. So we're going to be doing that now. And that's, in my opinion, the most complicated part of this video. So we're going to try to go slow. Okay, so the first thing we're going to have to do is in the header file. So we have all our code for the constructions. So what we're going to need is we're going to need a sphere. Because we notice in this simulation, we notice that our pickup coins, these ones also have a sphere. So we're first going to create a sphere component. So in the header file, we're going to say class uSphereComponent. Pointer uSphereComponent. Let me get rid of that. Pointer. And this is going to be the magnetic, like the magnetic collider, I guess. Magnetic collider. So let's create this magnetic collider in the constructor for the pickup. So in here, I'm gonna paste that in, and I'm gonna say create default subobject u. Just gonna copy the data type uSphereComponent, and then I'm gonna say text sphere to detect if the ball close to our actor. Yeah. And so we're gonna save that. And what we're also gonna do is we're gonna create another component. So we're gonna be calling this component a magnetic curve asset. So in here, we're gonna make a new component. And we're going to say this new component. So we're going to need two components. One to store the timeline. So I'm going to say class UTimelineComponent. Pointer magnetic timeline. So this is just to store. Okay, so what does this? So what should this store? In this magnetic timeline, so we notice with the blueprints, we have in the event graph, we notice that the way we're able to accomplish this interaction in the blueprints is that we have this timeline, and all this timeline does is it has a series of values from 0 to 1. So every value in between that will be decimals of that. So 0.76, 0.83, and what we're doing is that you treat this as a percentage. So read the values, and a value of 0.06 corresponds to 6%. So the rationale is that we're going to use, and so the rationale is that we're using these values and we're attaching them to a Lerp. This Lerp is reading this alpha value, and what it's doing is it's closing the distance between A and B. So A corresponds to the ball, and B corresponds to the coin. So close the distance between the coin and the ball. And how much distance you should close should be determined by this curve. So in the event that you're like, I don't know, 0.6, close in 60%, get the pickup coin 60% closer to the ball in a time of 0.57. So in a time of 0.59, close the distance between the pickup and the ball by 0.65, which corresponds to 65%. So get the ball closer to get the pickup closer to the ball by 65%. So the way we're able to do this in C++ is we're first going to have to create that curve that we saw in the blueprints. this curve in here, we have to first create that. So the way we're able to create that is we're gonna go into the we're gonna go into our contents folder, and then we're gonna right click, new folder, and then we're gonna call this curves. Okay, and then we're gonna right click, and from there we're gonna go into miscellaneous, and then we're gonna notice there's a curves part. So we're gonna click on that, and then we're gonna click on the curve float, and I'm gonna call this magnetic curve underscore asset. So from there, I'm gonna double click on that, and I'm gonna right click and add a key. The first key is gonna be set to 0, 0, 0. And I'm gonna right click somewhere else, and then I'm gonna say add key. The second key is gonna correspond to 1, and then 1. And now we wanna smooth this out, so it's not, as rigid as this. So we're gonna right click on the corner, and we're gonna say auto. And this just smooths out the transitions. We're gonna say auto in here as well. So by doing this, now we have our magnetic curve exactly the same as the one in the blueprint. It's just that we have to create it separately. We have to create this asset separately from the C++. Now in the C++, so I made a mistake. Instead of it being a UTimeline component that stores the assets from the editor, from this magnetic curve asset, it's actually going to be a UCurve asset. So UCurve float. And then, so I'm just going to say magnetic curve asset. So we wouldn't have to create this in the C++. We wouldn't have to create this component like we did our magnetic collider or a rotating movement, because it already gets assigned in the editor. So what we're gonna do is instead just say uProperty, and from here we're just gonna say edit anywhere blueprint read write. Okay, so this is reading gets assigned in the editor. So we know that this gets assigned in the editor, and we already created our graph for that, this magnetic curve asset. So the way we're able to read the values in is we're using this curve float, which makes sense because when we created our graph, it was called a curve float. So it makes sense that the data type is a curve float in here as well. So now we're going back to our magnetic collider, and just to be safe, I'm gonna assign this a uProperty as well. So I'm gonna paste that in here. Blueprint read write, yeah, that sounds good. So I'm using a uProperty just to be safe. And so I created this magnetic collider. And so what I'm gonna do is just set the size. So magnetic, you can play around with these numbers. So I'm gonna yank. So there we go. And we're gonna say set initialize sphere radius. And I'm gonna just set that to 400. And one thing I want to do before I get too deep into this is I want to make sure I include the right header file. So for the sphere, the header file for that would be this. So just get that out of the way before it causes an error. So we have the sphere, and like what we did with our static mesh, where we created an interaction component. So in our static mesh, we created this add dynamic, and just so that our Unreal Engine calls this a function when it adds basically it adds an event listener, so that when the components do interact, it calls this function. So when the components do overlap with each other, it calls this function. We're going to do the same thing for our sphere as well. So we're going to call our function, let's see, so I'm going to copy this, and magnetic collider, or just like what we did with our static mesh. Actually, I'll just copy it from our static mesh. Yeah, so so everything from here. I'm going to copy that, and I'm going to paste that into the pickup because it's exactly the same. On component begin overlap, add dynamic this, and then now it's going to be the name. So it's going to be the name of our class. So address at a pick up colon, and then the name of our function. So I'm going to call this function on overlap start. And we need the right function signature, so I'm going to go back into my interaction. We need the right parameters, so I'm going to copy this, copy the U function as well as, so I'm going to copy the U function as well as with the WhenTouching, and I'm going to paste it in here. Magnetic collider. So we have our U function, WhenTouching, and so instead of calling this WhenTouching, I'm going to call this on overlap begin. So when the ball is overlapping with our sphere. So I'm going to create an implementation. So on overlap begin, and just like what we did with our interaction base, where we have this WhenTouching, I'm just going to copy this, copy all this code, and basically modify it in the pickup. So for the pickup, this on overlap begin. So change and then overlapping with sphere. Call this function, call the on overlap begin. Call the on overlap begin when something is overlapping with our magnetic collider, which is just a sphere which gets attached to the static mesh. The fact that I'm saying that makes me think, oh, let me attach my magnetic collider to the static mesh. So I'm going to copy that, paste that, and then arrow, set up attachment. And then set it up to the static mesh. And the static mesh is essentially the root component. So just to reiterate that, I'll say static mesh or root component equals static mesh. And this static mesh was defined in the interactionBase class. So I'm going to compile this. Okay, so it's complaining that the on overlap start. I called this on overlap start, but then when I actually defined the class, it was on overlap begin. So on overlap begin. Is that the right name? On overlap. I think so. So I'm going to compile that and see if that fixes it. Okay. So the casting. So the casting is fine if the cast succeeds. So I'll just get rid of this else. Because when the cast succeeds, I want it to do something completely different. Okay. Convertible. Oh, okay. So it's complaining about this A ball character, and it's really dumb. It was because I didn't include its header file. That's why it's complaining. that it can't cast it. Sometimes it gives you like really complicated error messages, but really it's because they have no idea what a cast is, or they have no idea what this data type is. So it failed to cast that data type. So our aball character, actually, since the pickup and the interaction are in the same directory, they'd probably be the same include header file. So I'm going to go into the pickup and then just paste that in. There we go. And then that should fix that error. Okay, so compiled. Okay, so we have our curve. So we have our curve that gets assigned in the editor. And we have our magnetic collider. But now what we're going to need is we're going to need a component. And then this component is going to be a timeline handler. So we're going to say class UTimeline component. And then we're going to say timeline start. Or we'll just say timeline. And so the reason we're creating this component is because we need something, we need a component that's responsible for starting the timeline. And so this component is basically that. So responsible for starting the timeline. So in our pickup CPP, so I'm gonna copy this and go into our pickup, and I'm gonna create this timeline component. So create default subobject UTimelineComponent. Okay, and then I'm gonna pass in a text. Gives us the ability to start our timeline. Okay, so with that being said, now if we go back to our interact function, or the on overlap begin, so this is the interact. So this is the interact for the when like something is when the static mesh is being touched by the ball, but this is the interaction for when the ball is touching the sphere for the static mesh. And so the sphere, so in the event that the sphere is casting the actor, and that, so in the event that the pickup is casting to an actor, and that actor can be downcasted to this aball character CPP, that means that the actor itself is something we should be interacting with, which means that our C++ coin is interacting with our C++ ball. And in the event that that does occur, then we want it to start our timeline. So now if we go back to in the event that our sphere is able to cast the actor, and it so happens to be a C++ ball character, and we know that because of this cast in here, in the event that that happens, then what we want to do is we want to start this timeline. Timeline component, start component. Timeline component, play from start. So it plays from the beginning. I'm just going to copy this just to make sure. And before I forget, so play from start. Play from start. And so before I forget, what I'm going to do is I'm going to include the proper header file. So in here, I'm going to include the timeline component header file. So we have the timeline component header file. It's complaining, but just ignore it. So this plays the timeline, but then what we have to do in addition is we have to make sure we need some connector that reads the values that we're taking from our editor and associates it with some function. So to do that, we're going to need another delegate, and that delegate, so we'll call that, so that delegate has to be an f on timeline float, and this f on timeline reads it essentially, like, it connects the values that we're reading from the graph to the code. So it's reading the 0.01 at time 0.2, and it's like passing it into the function. FOnTimelineFloat is responsible for taking the values in our editor and using it and passing it into a function. So we're gonna create that function in a bit, but so it's gonna be like the values from the curve. So it's essentially reading the values from the curve and then passing it into a function that we create. And that function is gonna update each timeline event. We need to include the proper header file. And so the header file for this FOnTimelineFloat would be include, and it would be components/TimelineComponent. And actually, since we included this in the header file, we don't need to include this again in the C++. But since there's an include guard for these timeline components, so if I hit F12, since there's an include guard, it's only going to be included once. So we don't need to worry about double including a header file. Okay, so we have this value from curve. So we need to configure this value from curves. And the way I'm going to do that is I'm going to actually use a void begin play function. So void begin play, and then I'm going to override this. So we didn't need this in the parent class, but I'm going to use this for the child class just because let's create an implementation. Just because I want to use this for setting up our values from curve. So the values from curve, so taking the values from our curve asset in here, and then reading it into the C++. So going back into the values from curve, I'm going to go into the pickup, and in the begin play, what I'm going to say is I'm first going to call the super for the begin play. So super : begin play, and I'm going to put a semicolon. The first thing I want to check is if I said that this magnetic curve asset gets assigned in the editor. So we want to do a check before we even do any of our logic to see if the magnetic curve asset is defined. If it is defined, that means we know that it's been assigned and it can proceed with its logic. So I'm going to copy this magnetic curve asset, and I'm going to paste it in there. And so if this is defined, that means it was assigned in the editor. Okay? So we have our magnetic curve, and then what we're going to use is the values from curve. Just going to copy it. Values from curve, and then paste it into the pickup. And what I'm going to do is I'm going to bind. So I'm going to say .bind U function. And by doing this, what I want to say is bind this class to a function, and then this function is going to be named fname, and I'll call this timeline update. Timeline update. Okay, so get rid of that. And now this is like where everything starts connecting. Okay, so now that we have binded our values from curve, what we can do is we're going to be using our timeline component, which we have defined in the constructor in here. And its responsibility is not just to start the timeline, as we have called in here, not just to start the timeline, but it's also responsible for assigning the values. So for a timeline component, I'll just copy it. So not only is it going to start the timeline, but it's also responsible for updating the timeline. So add interp float, and what it's going to take is it's going to take the first value is going to be our magnetic curve asset, and this magnetic curve asset again is an asset that gets assigned in the editor, which is why we first check, is the magnetic curve asset defined? If it was never assigned in the editor, it wouldn't execute this code. So check if it's defined, and from here I'll just copy it from the if condition and paste it there. Magnetic curve asset, and then we're gonna take the values from curve. And then we're gonna assign an f name, and we're gonna say this is alpha. So essentially what this line is doing is it's saying use the timeline component is gonna add an interp float, and all this does is it looks at the magnetic curve asset, which again gets assigned through the editor. It takes that value and then it stores it into the values from curve. And the value from curve is binded to this function. So when this value gets assigned from the magnetic curve asset, it's going to call this timeline update function. And the timeline component, it's responsible for both starting the timeline, but it's also responsible for updating it with its new values. So when it happens to be a value of like 0.2, or the time should be 0.2. When the time is 0.2, update the value to 0.1. When the value is when the time is 0.3, update the value to 0.216. This magnetic timeline curve, or the magnetic timeline, so this timeline component is responsible for starting this timeline, but it's also responsible for updating the values. And the way it does that is it uses the add interp float function, and it takes the values from the magnetic curve asset and stores it into the values from curve. This values from curve is a delegate which is bounded to this timeline update function. And this timeline update function, what we're gonna do with this is we're gonna make it so that it does the Lerp. So in the blueprints, we notice that we have this timeline in here, and what it did is we have our alpha values the Lerp takes in. So in this case, our alpha values, this alpha, would be our values from curve. So our values from curve corresponds to the alpha that's being set into the Lerp. So essentially what our function will be doing, this timeline update function, all we're wanting it to do is we want it to essentially act as the Lerp. So all we're gonna do in that timeline update function is we're gonna call the Lerp from the timeline update function. So yeah, so we've created our timeline, and this distance percentage would be represented as our values from curve. That's like the values from curve. And then this gets bounded to a function, which is timeline update, and our timeline update function essentially does the Lerp, and then it will set the actor location. So this part here will be called in our update timeline function. So now going back into this, we're gonna, I'm just gonna add a couple of extra things before we create our function. It's not necessary, but it's helpful to have. And so we're gonna create set timeline component, and I'm gonna say set looping. I'm gonna set that to true. So just loop each time the timeline gets started, or each time the timeline re-begins. And the second one is the time dilation. So there are certain effects that you can include in Unreal Engine to slow down time. What this set time dilation set ignore time dilation does is it says, okay, even if the timeline is slowed down, I still want the speed of the code not to be slowed down. So I don't want this timeline to be slowed down due to the effects of the world being slowed down. If you didn't want to ignore the time dilation, then you would have set this to false. So now we're going to create our function that we just named in here, TimelineUpdate. So we're going to go into our blueprints, and then I'm going to say void timeline. What did I name it? I'm just going to copy the name. And this timeline update is going to be taking in a float, and this float will be the percentage. So I'm going to create an implementation for this. So since we're lerping between two components, the first component is our ball, or the first component is our pickup, and the second component is our ball, which is defined here. So this is part of the location of our ball, and this is the location of our coin. So since it's lerping between these two values, before I even write my code, I want to make sure that the overlapping ball, so the reference that I declared in here, the overlapping ball character, I want to make sure that that's defined. So I'm going to put that in here. Okay. And after that, I'm going to be doing the lerping. So I'm going to say f vector and final location and fmath lerp. So we have this lerp function, and what we're going to say is get actor location. So the actor location would be the location of our ball, or no, sorry, the location of our pickup. And the second location is going to be the thing. So this first location is the object we're trying to move, and the second location is the object we're trying to move to. So take the coin and move it to the ball. So it would be overlapping ball character, and then arrow get actor location. Okay, so then after that, we're gonna say how much we should reduce this distance, and the distance we're reducing by is the percentage. And so since it gets already bounded by this function in here, all we would need to pass in is the percentage. So we have that. And at the very end, all we say is set actor location. And then the set actor location will be the final location. So we notice that this matches our blueprints, our blueprint code. So we notice this matches our blueprint code verbatim, and that we use this lerp. We have these two objects. We did this cast, and we had this distance percentage, and we had our alpha. So I tried to make things as close to their names as the blueprint side. So I tried to make their names identical. So this new location, I guess I called it final location. Put it new location. There we go. This seems to be about it for the lerping. So we're going to be testing this out. So first going to compile and see how many compiler errors we have. Okay, so that failed pretty quick. Pickup.h. Okay, so it's complaining about line 8 in the header file. Where the hell is line 8? Oh, okay. You should leave this header file. So the last thing that needs to be included in the header file will be the generated.h file. So I'm gonna compile that. Okay. Oh, I do know why it's complaining about this. So it's because I forgot to include one of the header files, and that is the one for the lerp. So this fmath lerp. Okay, so it's complaining about this. Yeah, figured. A lerp no matching overloaded function. Yeah, the lerp function is included inside the Kismet library. So I'm going to include it here. Kismet, and then that should fix that error. For some reason I chose overlapping component. That's a wrong argument. So I'm gonna copy this overlapping ball character, because this was the reference I used in our parent class. And there we go. And build it. Okay, so it compiled. So it compiled, and so I'm gonna compile this in the editor, and then we're gonna be testing this in the editor. One thing I'm gonna do is I'm just gonna reparent this. So I'm gonna delete this. And the reason I'm doing this is because each time, the reason I'm reparenting it is because each time you call the add dynamic in, like for example, here we call this onComponent add dynamic. And because we did that, I wanted to, since we already created the blueprint, this add dynamic won't update. So we had to make sure any add dynamics we have, we do it in the C++ before we parent it. So now that I'm going to parent it again, I know it should work because I added, all the dynamics which are related to the interaction system that we built before I made the blueprint base class. So I'm gonna create that. And so now we have all these components. So we have our static mesh. So again, I'll just use the cylinder for this one. The second one gives us the ability to start our time. Oh, so it gives us the ability to start our timeline, but also update it as well. And then we have our sphere, which is the magnetic collider. So if we compile this, one thing I also want to make sure is that for some reason it doesn't update well for the overlap collision all. So I'll just set it in the editor. So I'll save that. Magnetic curve asset. Okay, that's strange. So typically when this happens, where I have a component and I expose it to the editor, but it doesn't register. Okay, so typically when this happens, I'll just close the editor and open it again. Can I get rid of this pickup? Add it back in here. And okay, there we go. So now that I close it and open it again, it updated the magnetic curve asset. So this is the magnetic curve asset. And this corresponds to the thing we declared in here. And this also will correspond to the thing we're gonna be taking the values from and then storing them into our values from curve. And our values from curve will be calling this update function, which will be doing the lerping. And our timeline component is essentially managing all this by starting the timeline, as well as taking the values from the curve and then putting it into the values from curve, delegate. So if we go back here, and now the curve folder, I called it magnetic curve asset. So if we go here, magnetic curve asset, and this magnetic curve is this one. So now with everything defined, it should be able to execute this begin play, and then it will be able to call the lerp, granted the casting works. So let's get rid of that and get our interaction, our C++ interaction. So now let's test it out. So we have our coin, we get close to it, it says overlapping with sphere. Oh, okay. So one thing I didn't think about is that I called this overlapping ball thinking that if I made a call to the parent function for this interact, then would be able to cast it. But that's not in fact the case, because this interaction function WhenTouching that we called and we stored a reference to, it only gets called when the ball is touching the coin. And so up until that point, it won't contain a reference to this overlapping ball character, which means this if condition will always result in null because we haven't stored a reference for our overlapping vol character. And because of that, I'm going to have to get rid of this and use a reference, so make a new reference. So I'm going to go into our interactionBase and overlapping vol character. So I'll do the same thing and then paste it into our pickup.h overlapping vol character. And just like what we did with our pickup.h, where if the casting was defined, I'll say the overlapping ball character will be equal to overlapping ball. Exactly what I did with the parent class. Because we need to know, we need to have the reference for our ball way before it even touches the ball. We need to have a reference for our ball way before it touches the ball so that we can activate this Lerp function. So in here, overlapping ball, I might just give it a different name, overlapping pickup ball or something. Ball. So I'm gonna copy that. I'm gonna paste that in here. And here, I'll paste that. And I'll say this is equal to overlapping ball. There we go. So now we properly have a reference for our ball before it gets, we probably have a reference to our ball location here. So this wouldn't be null anymore, because once it's able to be casted, we're like, okay, cast it, then store a reference to it so that we can call it into the Lerp function in here. Okay, so it was able to compile it. So we have our ball, then hopefully overlapping. So this is one of the issues with dynamics, is that when you change a piece of code in a dynamic, such as the overlap begin, then you have to reparent it each time. Or that's been my experience, at least, is that when you change a code in the overlap begin and you already made an instance, it won't update. So you have to make the instance again. So I'm gonna be deleting this and then making another child class. Go into the C++, interactions, pickup, right click, create blueprint base class, bp_pickup. And then we're going to store that interactions folder. Here we go. And now we're going to take that in here, magnetic curve asset. We're going to say magnetic curve asset, which is coming from here, and also assign it a static mesh. Okay, so for the third time, so assigning it a static mesh. So let's try it. So sometimes this happens and you just have to close the editor. I forgot about an important thing about the timeline update. Since we're binding it, since we're using an add dynamic, or since we're using a delegate to bind, like what we did with our interaction base, we would have to bind this to, or we would have to prefix this with a U function. And this is just to make it so that it gets binded correctly with when it gets called here, so that the editor is aware that this function exists and it can call it. I'm going to compile this, and hopefully that fixes the issue. Now in our pickup class, make sure we have the magnetic curve asset. We make sure we have this defined, so we have it assigned. Just test this and see if this works. Okay, so it crashed the last time. Because the reason, because when I did this if condition overlapping CPP vol, this was fine. But then if you actually looked at the location I passed it, it wasn't the overlapping CPP vol. it was an overlapping ball character, which is from the parent class. So that's why it was crashing. So if I go in here, change that to overlapping CPP ball, that should fix it. So let's compile that and save it, and hopefully we get our coins attracted to the ball character. Okay, so compiled. And so now let's test it out. It worked. Okay, so we got the magnetic coin to work. And it was, yeah, there we go. Magnetic coin works now. So this concludes the most difficult part of the video. So now all we have left are the two easier parts. We have the jump pad and we have the goal. The goal is really easy because I just printed something in the screen. We're gonna go with the jump pad then. So really it's 2. Okay, so let's start with the jump pad then. Okay, so we're gonna go into our C++ classes, and in the interactions folder, we notice that with our diagram, the jump pad is also inheriting from the interaction base, just like our pickup did. So we're gonna go into our interaction base, and then we're gonna right click on the interaction base, and then create C++ derived class. And then from there, we're gonna call this JumpPad. And now we're gonna create the class. Okay, so we got this error again, and it's probably just an include path. So we're gonna say yeah, and go into our header file. And for the JumpPad, it's including interaction. So let's get rid of that, and then that should fix it. So for the JumpPad, all we have to do is, since we already have the pre-built interact function from the parent class, all we have to say is override that. So interact, actually, let me just copy it from the parent class. Interaction base, and let me just copy that. And at the very end, I'm going to say override. There we go. And I'm going to create an implementation. And this is actually the only function we need. So we create our implementation, and from here, all we have to say is super : and it's going to be interact. So we're going to call the parent function interact. And then we're going to pass it the overlapping ball. It's fine. And we're doing this just so that it can, so it draws spheres. Spheres on the point of interaction. So this is just how much the ball flies up by. So I'm just going to define it by 300 units. Force gets applied the upward direction. There we go. So from here, I'm going to use an F vector, and I'm going to say a force vector. And all I'm going to do is, I don't want to pass it into the X or Y. I want to pass it into the Z coordinates. And so it's going to be ball position, or not ball position, ball height, where it's more descriptive and more accurate of what it's doing. So how much it should, how much force it should apply in the Z direction. Like at the very end of this, I want to say, I want to take my overlap ball, so I'm going to copy that. And I want to call a function within that ball called getStaticMesh. And so this getStaticMesh, actually, since our ball already has, since its static mesh is already public in here, I could just call static mesh, but for better practices, I'm gonna create a function called getStaticMesh. And what it's gonna return is a static mesh. And so it's gonna return static mesh. And I'm just doing this for better practices. Instead of just exposing the components to other classes, you would use function getters and setters to get the components, so that it's safer to get these components instead of just like making it public so that anything can modify it. So I'm going to use the static mesh. So I'm going to copy this. And in the JumpPad, I'm going to say get static mesh. So this will return this static mesh in here, the uStaticMesh. And this uStaticMesh is basically the static mesh of our ball. So take the static mesh of our ball and add an impulse. You could have also done add force as well. Either one would have been fine. So force vector, I just wanted to show you both, because in the first video I used add force. So in this video I wanted to use an add impulse to change it up. And so this add impulse, what it does, if we hit F12, okay, for some reason it doesn't want to show the definition, but what it takes as a second argument is the bone name. So I'm going to say fName, and I'm going to say it's random bone, and I'm just going to say it's none. So in here, random bone, and the last one is set acceleration to true. And yeah, we want to set the acceleration to true. And that's it. That's all we need for the JumpPad, because a lot of the logic that we made already, the casting and all this already got handled when we call this parent interact function. So we already know this overlap ball, like if it was able to pass through this line of code, we know that it will be able to call this function. Like it won't crash, because if this actor overlap ball isn't the actor, like if it was a blueprint actor, it wouldn't get past this line. So it would be a call to a function, but it never executes the rest of this code, just because it failed to cast in the parent class. So yeah, that's it. That's our JumpPad. So let's test it out. Oh, okay, there we go. Okay, so I know the problem. So the reason it's complaining is because this overlapping ball, it has no idea what an overlapping ball is. And that's because we didn't include the proper header file. So if we go to the C++, include the proper header file, that should fix that error. And then random bone name. And then I forgot the semicolon in here. Oh, okay, I see it. So this static mesh, uStaticMeshComponent. So there we go. So that should fix that. I was complaining about that. Oh, that's why. Add impulse is not a member of a uStaticMesh. Maybe I misspelled it. So add impulse, and that should fix it. Okay, so that fixed it. And so now we can test this out in the editor. So now I'm gonna go into the editor, and what I'm gonna do is I'm actually gonna close it so that oh, there we go, it fixed it. Okay, so I'm gonna right click and create a blueprint base class and bp_JumpPad. And I'm gonna say cpp interaction. So create that. And now since it inherits from the interaction base, and the interaction base has a static mesh, I want to say disk, SM radial disk. That's the one. Okay. So I'm going to save that. And I'm gonna take this. Okay, so one thing I did forget is the static mesh. I think it has to be set to overlap all. So pen blueprints. I click on the static mesh. We notice that the collisions, it's set to custom. So I'm just gonna set that to overlap all. And then I'm gonna compile that, save that. And now I'm gonna go in, gonna hit the ball. Ooh, okay, there we go. We have our jump pad. Okay, and it even draws the globes for when the interaction occurs. So now the last thing we have left is the end goal. So let's make that. So like the others, the end goal is gonna be inheriting from the interaction base. So I'm gonna right click, create C++ blueprint, flag. So this is like the Mario flag. I guess you could think of it that way. And then we're going to create a class. Okay, so it didn't compile. Let's see. And it's probably because that header file. So if we say yeah, and so it's including interaction base. So it just has to include interaction base directly. And so what we're going to do is we're first going to make a constructor. And the reason I'm making this constructor is because I want to create a component, and this component is going to be responsible for rotating the class, or rotating the flag. And this is no different than what we did for our pickup. So I'm actually going to go into our pickup, and let's see, rotating movement. So I'm going to copy that, and I'm going to paste that for our flag. Okay, and then I'm going to override. So like what we did with our JumpPad, I'm going to override the interact function that the parent does. So I'm going to paste that in. And I'm going to create implementation. Okay, from there, I'm going to create an implementation for both my constructor and it's going to be public. So I'm going to create an implementation for both my constructor and my interact function. So for the constructor, what I'm going to do is I'm going to copy this rotating movement and just create it. So not too bad. Rotating movement equals create default subobject U rotating movement. And then from there, what we can do is we can add a text and rotating flag. So we have our rotating movement, and then I guess we can say the root component, just to be safe, is the static mesh. Okay, from there, oh, okay, this was supposed to be in the constructor. Let me paste this into the constructor. And actually, let me move this constructor up. There we go. And so for our interact function, what we're going to say is call the parent interact, so still draw the globes. And overlapping ball. Okay, that's perfect. All we're going to do is a print string. So uprint string, and we're going to say 10, and we're going to make the color magenta, or let's do orange. And we're going to say the text is you reach the end of the level. Maybe in the future we can add some effects. Reached the end of the level. There we go. And this should be it. So let's compile that and test this and hopefully conclude the video. Still, what is it complaining about? Oh, it's because I'm using this overlap ball and I didn't include the proper header file. So let's include the header file. And then that should fix it. Okay, so it's because I used the rotating movement and I forgot to include the header file. So where is the header file for rotating movement? So in here, I'm gonna create the rotating and save that and then compile that. And hopefully that's the last error we have in our program. Okay, so it compiled. And now let's test it. So let's right click and create a blueprint based class. And I'll say BP_flag. And then I'll store that in the C++ interaction. And then from there, we have our rotating movement. So what should we use for the cursor pointer? Sure, that kind of looks like a flag. Okay. And we'll make sure that its collisions are set to overlap all. We're going to copy that, or we're going to save that. And now, if we take this and we play, so we touch it, it says you reached the end of the level. So this concludes our video. I hope you enjoyed it. Please leave a like if you do. And as always, let me know if there are anything you're wanting me to cover in future videos. I was thinking of maybe this would be a good point to talk about, for the next video I was thinking this would maybe be a good point to talk about widgets, but I'm not necessarily sure. So let me know in the comments below.